This is an exciting moment for me as rector of Tel Aviv University, especially given my ties with the Faculty of Engineering and with the type of technologies that are being launched to space here for the first time. This is a fantastic era for people who care about technology, whether they are users of technology or developers of technology. The idea that a small group of people can build a device in the size of a milk container and launch it to space is no less than mind-blowing. In addition to the technological achievement by itself, this is also an inspiring process for teaching and learning, and it is difficult to think of a more effective example of project-based learning, which is a process that we've all been interested for a very long time. So I want to congratulate all of us for this impressive achievement and thank the people involved in it. In particular, Mayor Ariel and Offer Amrani, who invested their soul in this project. Colin Price was also part of this endeavor. And of course, the students, Tomer and Idan and Dolev, who have worked on it and are responsible for most of the things that happened, and the engineers that guided them and contributed from their experience. I also want to acknowledge the funding from Mafat and the collaboration with Mamag Sorek in whatever concerns the payload of this mission. From what I understand, it is a matter of 2 to 3 weeks until we should hear from this satellite and know that everything is functioning well and that it is in orbit and everything is working. So let's keep our fingers crossed and hope for the best. Thank you all.
היום אנחנו השלמנו את הבדיקות בתום הבנייה של הלוויין הראשון הזעיר של אוניברסיטת תל אביב.
הלוויין שבנינו כאן באוניברסיטת תל אביב, המטרה שלו זה לבצע ניטור של סביבת חלל בגובה שקשה לחקור אותו, של מתחת ל-400 קילומטר.
התוצרים של המדידות שלנו יספקו את האינפורמציה שבעזרתה אפשר יהיה לשפר את האיכות של לוויינים עתידיים. וזו פעם ראשונה שדבר כזה נעשה באקדמיה הישראלית.
הפלטפורמה שאותה אנחנו בנינו, פלטפורמת החלל, זה בעצם לוויין זעיר בגודל של קרטון חלב. ובתוך הגודל הזה הצלחנו לדחוס מוצר טכנולוגי ומדעי ממדרגה ראשונה.
הסוללות, המחשב, הכל מאוד קטן יושב כאן בפנים. הפאנלים הסולאריים, ולכן אפשר לעשות הכל מאוד קטן, הכל מודולרי.
ייחודו של פרויקט הלוויין הוא בהיותו אינטרדיסציפלינרי, שמשלב תחומי ידע שונים, ובהתאם הוא בוצע בשיתוף פעולה בין פקולטות שונות, הפקולטה להנדסה והפקולטה למדעים מדויקים, ובית ספר פורטר למדעי כדור הארץ.
יש איזשהו גל שסוחף את כל האוניברסיטה עכשיו בכל העולם לבנות לוויינים כאלה ולהיכנס לתחום הזה שאנחנו קוראים חלל חדש. וגם אוניברסיטת תל אביב, אנחנו רוצים להיות חלק מהגל הזה, ולכן הקמנו מרכז בתוך האוניברסיטה, לננו-לוויינים וחלל חדש. זה כולל חוקרים וסטודנטים מכל הפקולטות, וחלק מהפרויקט הזה זה גם לבנות לוויינים על ידי הסטודנטים שלנו כאן באוניברסיטה.
Tel Aviv University soars to space. Welcome to our very special broadcast of the first nano-satellite that Tel Aviv University is launching to space. We would like first to thank our rector, Professor Steif, and of course to thank the leadership of the university, our president, Professor Porat, and our chairman of the board, Professor Frankel, for their ongoing support. I'd like to begin by not only welcoming all of you at home, but also welcoming our panelists. We have with us today a very esteemed group of people. All are directly involved with this project. I'd like to start with Professor Colin Price, who is the head of the Porter School of the Environment and Earth Sciences. On this side, we have Dr. Offer Amrani from the School of Electrical Engineering, who also served as the lead scientist of the nanosatellite project. We have right next to me, to my left, your right, Dr. Meir Ariel, director of Tel Aviv University's Nanosatellite Center. To my right, your left, Sharon Mishal, who is with the Konstantinos School of Education Nano-Satellite Center, and she will tell us about how those two things are connected, education and nanosatellites. And last but not least is Irina Tsiganov, who, like me, is a graduate of this university, a proud graduate, I may say, and she comes from the School of Mechanical Engineering. My name is Ido. I am a graduate of this university, and I am very, very happy to be your humble moderator today. First question goes to Professor Price. What is the new space? Everybody's talking about civil engagement in space research. Tell us about it.
So new space is a revolution in the civilian space industry. It's because of we have technologies which we can now make things a lot smaller, standardized equipment, and so today we can actually send satellites to space from universities, even from high schools, from startup companies, and this is very different to the old space. In the old space you needed really the big players. You had NASA, the European Space Agency, Israel Space Agency, and nobody could really compete with them. Today, the new space, we can have these very small satellites the size of a shoebox, and our students in Tel Aviv can actually build them and send them to space.
Professor Ariel, can you share with us a little bit about the history of the Israeli space program? Because we don't really think of Israel as a big player in the space of space. Tell us about it.
Well, in Israel, like some other countries, the space race started as a means to achieve national security goals. Following the peace accord with Egypt in 1980, Israel needed a means of monitoring the vast expanses of the Sinai Desert without the ability of actually flying over the area. And the only solution was watching the area from space. And accordingly, the first satellites of Israel were all reconnaissance satellites, the Ophek series. Ophek 1 was launched in 1988. It was launched into low Earth orbit for obvious reasons. You want to be close to the target observed. And later, space became a catalyst for the industry and the economy with the telecom series of Amos and Ophek. Both satellites were designed and manufactured by Israel Aerospace Industry. Amos satellites are launched to the geostationary belt, some 36,000 kilometers above the equator, where they follow the direction of Earth. Those two examples are of old space, where the space domain was dominated by government and by, as Professor Price said, by giant companies like Israel Aerospace Industries. This is a magnificent achievement of the industry. But the new space revolution in Israel started some 7 years ago with the launch of Duchifat by the Herzliya Science Center, which is actually a high school. And since then, several nanosatellites were launched, making Israel a player in the new space arena. Some say a major player in the new space arena.
Dr. Amrani, I'd like to turn to you. We just heard from Professor Price that those nanosatellites can be very, very small and light. What can you tell us about the process of how you designed it, how you built it, and also say a word about how students were involved in the process?
Yes, thank you for this question. It's a tiny satellite. It weighs 2.5 kilos, and it is 10 by 10 by 30 centimeters in measurements. It has two main sections, the avionics and the payload. Avionics has to do with the safekeeping and the life of the satellite itself. It makes the satellite tick. It contains the batteries, the solar panels, the onboard computer, and the radio to communicate with the Earth. Everything was built by our students here at Tel Aviv University. The other section of the satellite is the payload. It has to do with the mission, with the scientific mission. In our satellite, we have sensors for cosmic radiation and oxygen atoms. And this section, the mission, was designed and built by our colleagues from the SOREC Nuclear Research Center, the Environmental Space Department.
And I should say that the colleagues at the SOREC Nuclear Research Center were of great help in this project, and we owe them a big debt of gratitude. Let me ask you one more question for our viewers from all over the world. People are watching us right now. If they would like to come post-COVID-19 to visit campus, what can you show them physically when they actually come to the school?
Oh, there's a lot to be seen. We have 2 clean rooms with all the equipment that's required for building and testing the satellites, and it's very interesting to see.
Wonderful. So you're all invited. I'm also told that Dr. Amrani and his students actually built a huge antenna on the roof of the building, so we can actually visit the antenna.
Yes, you can visit the antenna. It's an automatic system.
Amazing.
The antennas track the satellite whenever it passes over the country.
And I should mention also it's the first ever project built by students that is being launched to space. And that's a wonderful segue to you, Sharon. Tell us about, first of all, the connection between the School of Education and this project, and secondly, about the student involvement.
Yes. There were high school students that was involved in this project that came from different places in Israel. These students were also participated in other programs, the Duchifat program and the Tevel program, which are programs where high school students build nanosatellites and launch them into space. We had schools that come from various places in Israel, and they all work together and for building the satellites and, of course, after the launch, operating them in space. These students were also involved in this project, in the Tausat project, and they were involved in writing the software that operated the satellite in space, testing the satellites, and also preparing the ground station for communicating with the satellite after it's being launched.
Amazing, amazing. Thank you so much for all that you do. One of the issues that top our agenda is, especially in North America, because of what happened in recent months, is the issue of racial inequality, corporate responsibility, social impact. These are all terms that are extremely familiar to our viewers and especially to our donors, who many of them are watching us right now. And this project, as I understand, served as a wonderful platform for the celebration of diversity, especially when we're talking about the ability of young women in science to express themselves. What can you tell us about that?
We believe that all students deserve the opportunity to participate in such a meaningful project. Students from the center of Israel, as well as students from the periphery, men and women. And that's why one of our main guidelines is that in all of our projects, we are integrating students from all kinds of cultural and religious backgrounds. It's important for students from Tel Aviv and from the center of Israel to work with students from the periphery of Israel, from Taibe, Natzeret, Ofakim. And it really has great impact and contribution for all of them. Also, students and people that come from different backgrounds have different perspectives, and they have different solutions for the same problem, which is really interesting to see.
Thank you so much, Owen. Dr. Ariel, did you also feel that this project was a celebration of the university's diversity?
Yeah, because altogether on those projects were maybe 200 or 300 kids from all over the country working together in harmonious partnership. Kids in state education, Muslim students, Jewish students, girls, boys, and when you put them in the same class, they don't feel that they come from a different background. They can work together, although sometimes they come from a different background and sometimes they speak a different language. But when they are working towards a mutual goal, they do it in harmonious partnership without paying attention to the differences between them. And this kind of projects not only serve as magnet for science studies, but also as as a basis for self-esteem and for self-competence, not only for the students, but for the parents, the teachers, and the entire community.
Thank you. Irina, you're a product of this university. I may say a wonderful example of the excellence of Tel Aviv University. How do you feel today when we're about to do something so historic? And tell us how you're connected to this project.
Well, I'm very excited to be here and to take part in this project. We were searching, me and my friends, Melody Korman-Shadmi and Ofer Katz, we were searching for an interesting, unique project for our senior year. And we heard that the university is opening a new nano-satellite center. And we immediately understood that it's our once-in-a-lifetime opportunity to do such thing. We asked to be the mechanical team of this project, and we were approved. We joined this project from its very beginning when there was actually no satellite yet. So we had to do a lot of preliminary work, such as preparing the model, a very detailed computer model to understand how it will be constructed and all the parts that need to be in it. It also helped us to help the Sorek Center to plan the payload that we also built later on by our own hands. That was very, very exciting. We designed 5 different devices to work with the satellite here on Earth in very different stages, from its construction to the tests in the vacuum chamber and the vibration tests. We also did a lot of strength analysis to prove that it will stand in the vibrations in the launch.
Now, can you tell us a little bit about yourself?
I finished my studies this year as a mechanical engineer and in the schools of geophysics. And that was a very interesting program of 4.5 years. Today I work in a slightly different direction, but space is definitely a hobby.
I served as Israel's representative in North America for many, many years. And one of the things that bothered me is that the issue of the environment was never on top of the agenda of Israel officially. As Dr. Ariel mentioned, it always has something to do with Israel's defense and Israel's security. How do you see the connection between this project and the efforts to raise the level of awareness to the entire issue of the environment and the role of your school, of the Porter School, in this process?
Well, the reason that I was interested in this project in the start, and why we are interested in continuing, is because we want to use these small satellites as a tool to monitor the environment. Today, as you know, climate change is one of the biggest issues globally, and the only way we can really monitor places where people don't live, like the polar caps, the rainforest, is with satellites. The ozone hole was discovered because of satellites going over the South Pole and measuring the data there. So we want to use these satellites as a tool to study the environment, whether it's agriculture, deforestation. And so this is the interdisciplinary nature here at Tel Aviv, that we have people from engineering who will actually build the satellites. We have the scientists who come with the scientific questions, training the students, and we all work together in these areas. But definitely environment is one of the main goals that we have in the Porter School, to use these satellites to study the environment.
And that leads to a question to Dr. Ariel. How this project is going to improve Israel's standing or Israel's positioning in the community of researchers and scientists and practitioners in the field of civil space?
Well, first of all, space is perceived as an indication of global leadership. Still, Israel belongs to a club, or an elite club, which is nicknamed the Space Club, of 11 countries, having the capability of not only building satellites, but also launching them into space using their own launchers. So that's the basic idea. Unfortunately, space capabilities are still linked to achieving nuclear capabilities. For example, North Korea and Iran are members of the Space Club, but that's a discussion for another webinar. what I can say that is space is linked to other subjects at the forefront of technological and scientific arena. For example, space and quantum technology are synergistic. There's also a synergy between space and artificial intelligence. One example is that if you want to design a constellation of satellites that cover the entire planet, then you can use satellites that function as an array of measurements that continue to learn and evolve after launch. So you can base your designs on networks that are based on what is called unsupervised learning, where the network has to learn by its own how to achieve optimum coverage. And there are many examples for such projects. So basically, using satellite technology and space technology comes in synergy with other subjects at the forefront of science. And if successful, they can contribute to Israel's prestige and standing in the global arena.
Which leads to the specifics of the nanosatellite. So we know it's 400 meters above sea level, right? 400 kilometers yes. Altitude. We know it orbits the land once every 90 minutes.
Right.
What kind of information our nanosatellite is going to collect, and how this information is going to be analyzed, and what impact will it have on our understanding of life in space?
So we're going to sense for cosmic radiation and oxygen atoms in space. It is crucial to understand the flux of these particles, because they have a terrible impact on human beings and also on electronics in space. So we really want to be able to study this and devise new measures for protecting electronics and human beings in space.
And when you say that it's a dangerous environment, do you see in the far future a situation where we are sophisticated enough, advanced enough to develop ways to actually sustain life in space?
Yes, absolutely. I think it's a must. It's a challenging topic that we have to take care of if we want to be able to travel into space. But it also has implications on life on Earth. I mean, the cosmic radiation is harmful. It's ionizing and it causes cancer. So before being able to devise new equipment and measures to help people survive under this radiation, we really have to first study and understand what's the situation is up there in space.
One of the beautiful things about this project is that it allowed various departments within the university to take place. If you may, this was the epitome of the interdisciplinary approach. And I'd like to turn to Professor Price and ask a question about how do you see that collaboration between the various departments, and how do you connect this project to the issue that you talk a lot about of space weather, or the weather conditions up in space?
So space weather, similar to the Earth's weather, we have weather in space. People don't know really that we have storms in space, and these storms are actually on the surface of the sun, which is 150 million kilometers from here. But when we have storms on the sun ejects lots of material, what we call these cosmic rays or energetic particles, traveling at maybe hundreds, if not thousands of kilometers per second. And so these, when they hit the Earth, as well as X-rays and other things, they impact the environment around us. So we need scientists to understand solar physics, understand what's happening in the Earth's atmosphere. We need people to understand how these are going to impact on astronauts or on the satellites. These also have impacts on other things like GPS. If we're all using Waze today and we have a solar storm, our GPS can be knocked out. And in extreme cases, we can actually have power failures at the ground. So we need the scientists to understand the processes. We need the engineers to actually build the satellites so we can actually get the information. and we need the students, the education side of it, and in the future, maybe even law. We may need people to deal with regulation in space and what do we do, what's the law in space and who can use it and what's the regulations there. And obviously many people in different areas from medicine to life sciences want to do experiments in space, in microgravity, and so they want to use this tool for their research in space. So it really involves everyone from around campus.
And I think that the interdisciplinary approach is also a key to the adaptability of humankind, which is really the main reason for our survivability as a species. And no less important is the fact that it inspires young people like Irina and Sharon. And I'd like to ask you, Dr. Ariel, how did you experience that interdisciplinary collaboration?
Well, this is what's cool about space, is that it is interdisciplinary, combining various scientific fields such as electrical and mechanical engineering and physics and computer science and remote sensing and so forth. And the variety of research fields allows each and every student to choose a topic close to his or her heart and carry out research work in that area.
Can you share with us a little bit about the roadmap for future projects? We know that we are very happy with this project. It's a big achievement for the university, but we aspire for more. Tell us.
Well, we have a very clear roadmap ahead. First of all, in June, 8 nanosatellites built by 200 high school kids throughout the country will be launched. And those satellites carry retroreflectors that will be used to reflect laser beams delivered from Earth. And Tel Aviv University is responsible for the science part of this project. And it will be used as a first stage of building an optical communication satellite. And then later this year, we will be launching the second satellite of Tel Aviv University, unsurprisingly named Tausa-2. And again, it will carry an optical payload. And all those 9 satellites altogether will serve as precursors for the next mega project of Tel Aviv University, the so-called Quantau. Quantau is a quantum communication satellite that will be used for encryption from space. And if we will able to achieve this project and launch it successfully, then I'm sure that it will contribute to Israel's prestige and will put Tel Aviv University at the forefront of science research.
And there's no doubt in my mind that many of the people watching us right now are extremely interested in ways to be involved. And so tell us, if someone would like to be involved, someone would like to help the project, what should they do?
Well, we have a nanosatellite center here at the university. The center is interdisciplinary, and of course students from all backgrounds are welcome, and from all degrees. I mean, starting with graduate students and PhD students, but also students that feel that they love this area. They want to take part in future projects, and you can approach either one of the panelists here and take part in a real project in R&D that.
Yeah, please call me.
So one of the ideas we had was to maybe have in the future a competition amongst the students to propose ideas for research in the future and maybe choose then the winning project. The beauty of the new space is that you can have an idea, you can build the satellite and launch it in 2 years. And that's the time of a master's thesis. It's less than a PhD. So a student can come with an idea and we can work on it, we can build it, launch it, get the data and write a thesis all in a few years. And so if people out there would like to support our students, we would kindly accept their help, and we want to start having these competitions so that we can fund students to have their own individual projects.
And I may add that all of our panelists are listed on the university's website. All you have to do is just Google up their name. I can only imagine how exciting this whole thing can be to a high schooler. And, you know, what I would like to do as we are preparing to close this incredibly interesting panel, I'd like to turn to you, Irina, and then to the rest of the panelists and ask you if there's a general statement that you'd like to make to our viewers, but how do you see the connection between this project and Israel's overall positioning, each and every person in his or her field? And so we'll start with you, Irina, because you're really a fresh graduate of this university, and there's no doubt in my mind that you'll be interested in being part of the second launch of the next satellite. So tell us, what do you think about this project in the big picture?
Well, it's hard to say if it will affect the industry in Israel, but after the Bereshit project, we saw a lot of enthusiasm and interest in the space field. And I believe that projects like this make space industry accessible again for all the public in the world and in Israel, of course. Many children are interested to know more, to be part of this project, and there are a lot of classes that made on this subject every time something that big happens. And I believe that there's a lot of space for new minds, new expertises, new jobs, and of course new research in this field. And we saw a lot of interest in us from different students in the university while we were in the project. We felt very in the spotlight. So we think that in the future, not only students from fields like geophysics and engineering that really directly connect to these fields of nanosatellites, but also researchers from a lot of fields will connect to that, and the research is is limited only by our imagination. That's what I think.
And that's really the legacy of Albert Einstein. Imagination is the key to everything, to advancement of knowledge. Professor Colin, please.
Well, Tel Aviv University is a research university, and also with obviously education, we want to train the next generation of space scientists, of Earth scientists. The university's actually signed a memorandum of understanding with 8 or 9 other universities which are also building CubeSats, a consortium called INSPIRE, and from Indonesia to Taiwan to the United States. And our wish is that we can collaborate with students and universities around the world to build joint satellites, not only Tel Aviv satellites, and to work. And this is the way both we can spread research, education, and obviously international collaboration.
Dr. Meir Ariel.
Much has been said of the impact of moon landing on science education in the United States, attracting young Americans to learn sciences and engineering. So we are looking to make the same effect, the Apollo effect, here in Israel. One interesting note is that Sharon and we have experience in working with R&D teams based purely on girls, because in some of the projects, religious schoolgirls, what is called ulpana, were taking part. And it was interesting to see that when boys were not around, the girls were showing not only excellent R&D capabilities, but also leadership and entrepreneurial qualities. So this is one lesson that we have from using space programs as a magnet for science studies.
It changes the conversation. Dr. Amrani.
Yes. There's only one thing I would like to add. We're already working on Tausat-2, the following satellite to be launched in a couple of months, hopefully, if everything goes well. This time, this satellite is going to be holding our homemade scientific payload. So it's very exciting, and we really want to call upon brilliant students to do the theoretical work, the practical work, the simulations that are involved in this project. So it's very important that we continue to be able to draw good students to learn engineering and sciences.
Thank you, and we'll end with you, Sharon.
Space is attractive, and building satellites is cool, and this whole field is attractive, and it's exciting, and it's cool for students. And If you want to promote studying scientific and technological subjects, and if you want to foster the natural curiosity of students, this is one of the best way to do it. We have to make space accessible for them from younger age. We're also now here in the university developing a new curricula to the Ministry of Education, to the physics department, that deals with space and satellite, so that every student can choose and learn these subjects early in school.
Well, and you all said very profound things. I'd like to add to that the view from the national point of view. I think this project has great national importance because, unfortunately, over the years, because of geopolitical constraints, Israel became known for its problems and more specifically for its geopolitical problems. And it's very rare for Israel to be mentioned in the news in the context of something as exciting as space exploration. And so you're not only doing a great service to science, not only doing a great service to Tel Aviv University, but you're also doing a great service to our country. I'd like to thank all of our panelists. I'd like to thank our colleagues at the Sorek Center for Nuclear Research. I'd like to thank our leaders at the university here that made this thing possible. And of course, to you, our guests, our viewers, and as a member of the Board of Governors, I'm proud to be here. Thank you all.
Thank you.
Thank you. Thank you.
Good evening, everybody, and a good and a healthy week to all viewers, and welcome to the Tel Aviv University Nano-Satellite Launch broadcast. My name is Meir Ariel, and I'm the director of the university's Nano-Satellite Center. In a few minutes, we'll be live broadcasting from the launch pad at the Wallops Island in Virginia. The broadcast will not last too long, but is guaranteed to be very suspenseful. ערב טוב ושבוע טוב לכל הצופות והצופים, וברוכים הבאים למשדר שיגור הלוויין טאוסת 1 של אוניברסיטת תל אביב. שמי מאיר אריאל ואני מנהל המרכז לננו-לוויינים של האוניברסיטה. בעוד 2-3 דקות נעבור בשידור ישיר אל כאן השיגור בוולופס איילנד, וירג'יניה. הסברים יינתנו באנגלית, במבטא אוקספורדי, כיאה ללוויין המשוגר על ידי מוסד אקדמי. אבל אל דאגה, על רוב ההסברים אחזור בעברית לטובת צופינו שאינם דוברים את השפה. There's a lot of tension here at the university. We can see at the small picture the launcher Antares smoking on the launch pad. The weather looks pretty nice, a bit chilly, about 2 degrees centigrade. With a bit of clouds, reasonable conditions for a launch. The pre-launch sequence has begun. In about 12 minutes, the rocket will be launched towards the International Space Station, and on board is the Tausat-1 nano-satellite, the first satellite of Tel Aviv University. You can see here the white smoke currently emitted. That is actually fuel vapor. In this case, liquid oxygen that boils at room temperature, and it is used as oxidizer in the first stage of the rocket. אז המתח כאן באוניברסיטה בשיאו, אנחנו יכולים לראות כאן בפינה הימנית תחתונה את המשגר אנטארס, מעשן לו בשלווה על כאן השיגור. אנחנו רואים שמזג האוויר נראה טוב למדי, קצת קריר, בערך 2 מעלות צלזיוס עם מעט עננות, תנאים סבירים לשיגור. נקווה שהשיגור יצא במועד, הספירה לאחור החלה, ובעוד אני רואה 13 דקות, הלוויין ישוגר אל עבר תחנת החלל הבינלאומית, ועל סיפונו הלוויין טאוסת 1, הראשון של אוניברסיטת תל אביב. אפשר לראות איזה, הטיל מעשן לו קלות, בעצם מדובר ברתיחה של החמצן הנוזלי, שמשמש כמחמצן בשלב הראשון, ורותח בטמפרטורת החדר. בינתיים בואו נראה קצת פרטים טכניים על הלוויין שלנו. Some technical details about the satellite. First slide. The satellite was designed and built from beginning to end and also passed all environmental testing at the university's Nano-Satellite Center. This is a joint venture by the faculties of engineering and exact scientists and the Porter School of Environment and Earth Sciences. The satellite was actually built by students and faculty from Tel Aviv University with the help of high school students from the Herzliya Science Center. Tausat-1 is the size of a so-called 3U. This is the actual size of the satellite, and weighs about 2.5 kilograms. The satellite is made of two main parts, the avionics or bus that includes all the essential systems, an airborne computer, electrical system with solar panels, a communication system, and an attitude control system. And the second part at the top is the payload built by the Sorek Nuclear Research Center. קצת פרטים על הלוויין, הוא נבנה, תוכנן ונבנה מתחילתו ועד סופו, וגם עבר את כל הבדיקות במרכז לננו-לוויינים של האוניברסיטה, שהוא מיזם משותף לפקולטות להנדסה ולמדעים מדויקים, ולבית ספר פורטר לסביבה ומדעי כדור הארץ. את הלוויין בנו סטודנטים וסגל מאוניברסיטת תל אביב, בסיוע של תלמידי תיכון ממרכז המדעים הרצליה. הלוויין Tausat-1 הוא בגודל של מה שקרוי 3U, זה 10 על 10 על 34 סנטימטר, שוקל 2.5 קילו בלבד, בנוי משני חלקים עיקריים, אביוניקה או בס, שזה כל המערכות החיוניות, מחשב, חשמל, פאנלים, מערכת תקשורת, בקרת הכוון וכו', ומטען יהודי שנבנה על ידי המרכז למחקר גרעיני סורק, שגם מבצע את המחקר המדעי. The satellite is commanded and controlled from the ground by the same students who have built it from two ground stations, one at Tel Aviv University and the other at the Herzliya Science Center. The satellite contains various types of radiation and heavy particle detectors that will collect data from its orbit and space, as well as an additional experiment deploying an arm under microgravity conditions. The arm is made of a smart material called shape memory polymer that has the ability to return from a deformed state to its original state as a result of an external trigger, in this case temperature change. This is the ISS, the International Space Station. The satellite will be launched to the ISS, and from there will be deployed within 3 weeks to its orbit in space. Here we see the space station, which is the largest man-made object in space, with a width of 109 meters, weighing about 450 tons. The station has been built in stages for 10 years, starting in 1998, and is operated by 5 agencies: NASA, the American, the European Space Agency ESA, the Russian Roscosmos, the Japanese JAXA, and the Canadian CSA. There are about 7 to 8 astronauts in it in any given moment, and the station is equipped with 2 robotic arms in the Canadian section and the Japanese section. Our satellite will be ejected into space from the Japanese part. All Cygnus missions are named after people who made significant contribution to spaceflight. This mission is named after the African-American mathematician Katherine Johnson, whose life story was immortalized in the wonderful film Hidden Figures. Johnson is one-of-a-kind example of breaking a glass ceiling, a black woman who participated in space mission planning between 1952 and 86 in a world that was not only male-dominated, but also one that has kept blacks from positions of influence in science and technology. Katherine Johnson passed away a year ago at the age of 101. כל משימות סיגנוס קרויות על שם אנשים שתרמו תרומה משמעותית לטיסה בחלל. המשימה הזאת נקראת על שם המתמטיקאית קתרין ג'ונסון, שסיפור חייה הונצח בסרט מאחורי המספרים. let's talk a bit about the launcher, Antares, a medium-sized two-stage launcher. The first stage is propelled by liquid fuel and the second by solid fuel. Liquid fuel rockets consist of a fuel and oxygen in liquid states. They are combined in a combustion chamber and ignited. The fuel flow to the engine can be controlled, and the engine can be turned off or on as needed. Solid fuel, on the other hand, consists of fuel and oxidizer that are pre-mixed in a solid form. So once the solid fuel is ignited, the resulting thrust cannot be regulated or turned off. Also, liquid fuel rockets have a better specific impulse, meaning that more energy is produced for each kilogram of propellant. On the other hand, solid fuel is more reliable, simpler, and cheaper to manufacture. In this launcher, the Antares, we have both. למשדר אנטאריס יש שני שלבים, הראשון מונע בדלק נוזלי, שני בדלק מוצק. עקרונית, היתרון העיקרי של נוזלי על מוצק זה אפשרות לשליטה על עוצמת הדחף, ובפרט האפשרות גם לכבות ולהדליק את המנוע, שזה יתרון בטיחותי חשוב בכל הנוגע לשלב הראשון של הטיל שמוצת על כאן השיגור. היתרון השני הוא יעילות אנרגטית גבוהה יותר. מצד שני, מנוע דלק מוצק הוא יותר פשוט ויותר אמין וגם בטוח יותר, לפחות בחלל. This is Cygnus, which is a cylindrical spacecraft that carries up to 3.5 tons of supply to the ISS. It is operational since 2013. It has two modules, a pressurized cargo module that holds the supplies for the ISS, and a service module which contains the propulsion system. Cygnus is also powered by a pair of solar arrays attached to the service module. So this is the module that carries all the supply, including Tausat-1. Interestingly, it is not reusable like the new launchers designed by SpaceX. And at the end of its mission, Cygnus is filled with waste from the ISS and then burns up when it re-enters the atmosphere. So on the way back, it functions as a glorified trash can. סיגנוס זאת החללית שנראית כמו קפסולה או מכל גלילי, היא משנת את ההספקה אל תחנת החלל במשקל של 3.5 טון. יש לו שני מודולים, מודול תא מטען, אליו טוענים את ההספקה, ומודול שירות שמכיל את מערכת ההנעה והניווט. מעניין לציין שהחללית הזאת אינה ניתנת לשימוש חוזר, כמו חלק מן החלליות והמשגרים החדשים שתוכננו על ידי SpaceX. So, בתום המשימה, המיכל הזה פשוט מתמלא בפסולת שהאסטרונאוטים מפנים מתחנת החלל, ואז נכנס לאטמוספירה ונשרף. כלומר, בדרך חזרה מדובר בסך הכל בפח אשפה בשווי של $80 מיליון. נעבור אולי לכאן השיגור. Let's go to the launch pad live.
MES1, we'll check 412. And we're now in terminal count. Phase 3 dynamic limit will be active at T-minus 3 minutes.
Three minutes and 15 seconds until launch. Terminal count targeting that exact liftoff time, 12:36 and 49 seconds. Tanks will be pressurized at about T-minus 40 seconds, and we'll be counting down to T0. Everything's good for launch today.
אנחנו 3 דקות לפני השיגור.
Auto sequence start. ODM bus voltages and currents in Havana. Copy all, LAC 1. GNC1, step 418, verify ready for nav mode.
LC GNC1, orb nav, ready for nav.
And Ops 2, you go to switch to nav. LC Ops 2, switch to nav.
Orb nav telemetry verified.
Copy all. Check 419 and check 420.
3 דקות וחצי לפני השיגור, המחשב של החללית משתלט בעצם על המשימה, ויש התנתקות מן החשמל החיצוני. אנחנו רואים את הטיל, שכאמור יש לו 2 שלבים, כל שלב בוער בערך 3 דקות. זאת אומרת, בסך הכל 6 דקות מספיקות כדי להביא את המשגר לגובה של 200 קילומטר. Each stage burns about 3 minutes, so 6 minutes are sufficient to bring the launcher to an altitude of about 200 kilometers at the same speed of the ISS, which is about 7.6 kilometers per second. That's about 27,000 kilometers per hour. And then another 2 days are required for signals for the capsule to catch the station and make the rendezvous in space.
T-minus 1 minute, 30 seconds.
דקה ו-30 שניות. דקה לשיגור, ההתרגשות בשיאה.
T-minus 1 minute on my mark.
בינתיים הכל מתקדם לפי התוכנית.
Mark.
We are less than 1 minute to the launch, and everything continues to progress smoothly. "30 seconds to the launch."
T-minus 30 seconds.
So I guess there is no turning back now. נראה שכבר אין דרך חזרה, 15 שניות לשיגור.
T-minus 10.
5 שניות.
5, 4, 3, 2, 1. We have engine ignition.
Main engine started. And we have liftoff up in Paris for NG-15 mission. The long flight facility. Engines are at 100%. Attitude, core pressures, and vehicle subsystems are nominal. The SS Katherine Johnson takes flight on this, the 59th anniversary of John Glenn's Mercury flight, carrying 8,000 pounds of cargo to the International Space Station. Good performance on the first stage so far. Engines at 100%. All systems nominal.
First stage operates smoothly.
Continues nominal performance. Engines at 100%. Good core pressures.
100%. המנוע עובד ב-100% מהתפוקה שלו. כאמור, בערך 3 דקות של בעירת.
Engines remain steady. Attitude nominal. Max Q. Attitude nominal. First stage passing through the area of maximum dynamic pressure on the rocket. 90 seconds into the flight.
Minute and a half into flight. Still everything looks...
This first stage burns for a little over 3 minutes, 3 minutes 18 seconds until main engine cutoff.
Main engine cutoff, 3 minutes and 18 seconds.
About 90 seconds to stage 1 burnout.
הדלק הנוזלי יעבוד 3 דקות ו-18 שניות בלבד.
Attitude nominal.
לאחר מכן החלק הראשון, השלב הראשון יושלך, והמנוע השני ייכנס לפעולה באמצעות דלק מוצק.
T+2 minutes. All subsystems continue in nominal performance.
כל המערכות עובדות בצורה נומינלית טובה. Then once the first stage is cut off,
subsystems are nominal. We'll be ready to
will
shift
be
down
ignited.
to 80% on the engines at 170.
The engine now is at 80%.
Startup slow throttle down.
Throttling down at 3 minutes into the flight. Main engine cutoff coming soon.
10 seconds to first engine cutoff.
Throttle down to 55%.
The engine is turned off gradually.
Main engine cutoff.
We have MECO, and Terry's entering into a coast stage. Fairing separation will occur about 30 seconds later. As we lose sight of the vehicle, now switching to animation.
Okay.
Some controlled
We lost
firings
sight of,
on the
vehicle,
interstage of the rocket.
So we switch to
Attitude nominal.
animation.
Good separation.
The altitude is about 100 kilometers.
20 seconds to stage 2 ignition.
In 20 seconds, the second stage will be ignited.
All subsystems nominal.
As you can see, the fairing
Fairing
is
separation.
discarded.
Interstage separation.
Confirmed fairing separation and interstage.
Fairing is the cover
Stage 2
that
ignition.
protects the signals.
Stage 2 ignition confirmed. Stage 2 is a solid rocket motor, burns for about 2 minutes 44 seconds.
So the second stage was ignited successfully.
Stage 2 will continue to burn for another approximately 2 minutes.
And it will bring Antares to an altitude of about 200 kilometers.
Altitude 138 kilometers.
And to the same speed of the ISS.
Mission time 300 seconds. Velocity 4.8 kilometers per second. Altitude 150 kilometers. All
The
systems
velocity
continue
is
to
about
perform
5
nominally.
kilometers per second.
Good calls,
But
5
it
minutes
is
15
expected to
seconds
reach
into today's flight.
7.6 kilometers per second, the same speed of the ISS.
Stage 2 motor pressure nominal.
So all the stages until now operate smoothly.
Attitude nominal. Altitude is 170 kilometers. Roughly 1 minute to stage 2 burnout.
In 60 seconds, the second engine will be cut off.
All stage 2 and GNC parameters continue to be nominal.
6 minutes 15 seconds into the flight, coming up on stage 2 burnout of that solid rocket motor. That'll initiate a 2-minute coast period until second stage separation.
Unlike the liquid motor, once the solid fuel motor is ignited, it cannot be turned off.
Stage 2 starting to tail off.
As you can see, we are almost at the
Roughly 15
velocity
seconds
of
to
the
burnout.
ISS.
Stage 2 burnout. Attitude nominal.
So Cygnus has
Stage
reached
2
the
burnout,
velocity
good
of
attitude.
the ISS,
We're in a
altitude of
coast period now.
185 kilometers. And now the
Cygnus
second stage
exposed
will be
after that
discarded.
fairing separation, and will continue to carry the second stage with it until about 9 minutes into the flight.
Nominal. Attitude nominal.
We have a few minutes to separation
Attitude
between
nominal.
the Cygnus and the second
Expected
stage.
attitude control system thruster firings received. continuing on course. Roughly 1 minute to payload separation.
Payload separation
altitude 185 kilometers.
בעוד דקה,
Velocity
החללית סיגנוס
7.5
תיפרד מהשלב
kilometers per
השני.
second. All systems continue to operate as expected.
בינתיים הכל עובד חלק. As you can see, the velocity of the second stage with Cygnus
Approximately 30 seconds
is
to
exactly the
spacecraft
velocity of
separation.
the ISS now.
Attitude nominal. Systems continue to perform as expected. Attitude corrections maintaining expectations.
LCGSO, I just released red team to the pad.
Copy that. Spacecraft separation.
Confirmed. 9 minutes into today's flight, Cygnus has separated from the second stage.
So Cygnus is now separated from the second stage and continues his journey to the ISS.
Okay, NG-15, excellent job today. Let's go ahead and wrap up through this post-launch checklist. And Prop 1, can you report on status of pulse purging?
So everybody's happy at the Mission Control Center. That's a good sign.
Check 430. And GNC1LC, when you have the Antares state factor to the Cygnus POC emailed, confirmed, give me a call back on step 431.
Copy and work.
From the Wallops Range Control Center in Wallops Island, Virginia, some celebratory fist bumps as they successfully delivered Cygnus into orbit, a 9-minute flight on top of Antares from Virginia Space's Mid-Atlantic Regional Spaceport into orbit. Cygnus now flying free. The SS Katherine Johnson in flight will make its 1.5-day journey, just a little shy of 2 days, to the International Space.
So we can see here how the Cygnus is docked to the ISS with the Canada arm, and then when it is docked, it will put into place by the Japanese astronaut. Yeah. Soichi Noguchi will capture Cygnus with the robotic arm, and after Cygnus capture, Mission Control in Houston will send ground commands to the station's arm to rotate and install it on the station's port facing Earth. This is how the Cygnus is docked to the ISS. And here we can see the hatch of the Cygnus open, and the Japanese astronaut that in charge of the robotic arm smiles at us. And then the satellite is expected to be deployed from the ISS within 3 weeks to the same orbit of the ISS. And that's also a very tense moment. Okay, so we are nearing the end of the broadcast. A very successful launch of Antares and Cygnus carrying on board the nanosatellite Tausat-1, now on its way to the station. We also hope for a successful capture by the station, and then 3 weeks from today, Tausat-1 will be deployed from the Japanese section of the station. More tense moments are expected within the first pass over Israel. We will then try to receive the first signs of life from the satellite to perform a systems checkup and verify that the satellite is functioning properly. And until then, Thank you for watching Tel Aviv University's first satellite launch broadcast. Good evening, and wishing you all a great and a healthy week ahead.